Everyone, and thank you for attending today's webinar, Reap the Benefits of a Distributed Cloud, sponsored by Juniper Networks. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be captured, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget with a question mark. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Towards the end of today's presentation, we'll ask for your feedback. A survey will pop open on your screen and will only take a minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available approximately one day after the event and can be accessed using the same audience link that was sent to you earlier today. I'd now like to turn the event over to Heavy Reading Senior Analyst Jim Hodges. Jim?
Hello, everyone. Thank you, Operator. So welcome, everyone. My name is Jim Hodges, and I will be the moderator for today's session. So in today's webinar, which is entitled Reap the Benefits of a Distributed Cloud, we're really going to focus and drill down and address the business and the technical benefits of deploying a distributed cloud to not only improve service delivery, but also put in place a future-proof architecture for new services and for bringing new scale to the cloud. But before we start, let me first introduce our speaker. Joining me today and presenting, we have with us from Juniper Networks is Wayne Chung. Wayne is the Director of Product Marketing of SDN and NFV at Juniper. So welcome, Wayne.
Thank you, Jim. Thank you for having me.
Okay, looking forward to your presentation. Okay, so let me go through the agenda briefly. So what we've really done today is we've pretty much structured today's presentation to first address kind of the various cloud configurations, including the distributed cloud, which is obviously the focus of today's event. So therefore, what we'll do is we'll really start pretty much by looking at both the technical and the business drivers for the distributed cloud. And then in the main section of today's presentation, Wayne will address really how to best implement the distributed cloud. He'll focus on the relationship of architecture to some of the technical and the business drivers that I'll introduce and touch upon. We will also conduct two audience polls to get your audience view on a number of the key themes and topics and discussion points from today's presentation. And then at the end, we'll have some time set aside for your questions as well. And as the operator said, you've got a tool there to be able to submit questions as they come up in today's session. Okay, so let's get started. So what I wanted to do is to really help us frame the discussion. I thought it'd be helpful pretty much to first kind of address what we mean by centralized versus distributed cloud. So I put this diagram up here of a centralized configuration and also with a distributed cloud. So essentially, as I've captured in the diagram, a distributed cloud is really one that can be deployed at the network edge in order to support enterprise services and compute requirements, but it can also have some components even on the customer prem as well. And obviously, there's now a lot of interest in distributed clouds, and I'm going to talk about the benefits in a minute. But I do want to point out that even distributed clouds can have a number of phases. So since the cloud architecture is inherently it's very flexible. So if you want to, if there's requirements, you can do things like you could deploy a number of different approaches in the distributed cloud. So for example, you could do things like support policy control, access routing, and even security enforcement. Essentially, or basically whatever your customer requirements are, you can deploy those functions in the distributed cloud or some even on CPE. And, some of these can run natively in the edge, or they can even run the centralized cloud, or it's even possible to have a hybrid configuration where some of the functions run in both locations. So, and as we're going to see in Wayne's presentation later on, things like policy control and security enforcement, I'd say, are really becoming key network capabilities because they do a lot of things to not only protect the network, but they also enable things such as service-driven approaches, such as service chaining, which we'll talk about. So, obviously that's kind of, the distributed architecture that we'll be focusing on. But let's talk a little bit about what the drivers are for deploying and implementing the distributed cloud. Let me start first with technical drivers, and I think you've probably seen some of these in other presentations. I'm just going to summarize them pretty quickly and move on. But I think you can, if you start with it from a technical perspective, for me it really comes down to kind of two different categories. The first is scale. Obviously, the distributed cloud, you can scale at the edge in response to customer demands, so you can meet and size your distributed cloud based on real customer demands in real time. And so therefore, it's a very flexible scale model. You're not provisioning or planning a network based on theoreticals. It's basically on customer demand. And then the second sort of group of drivers I sort of bunch together in what I call network transformation, and that obviously includes a number of different topics. The first is, as I said, the distributed cloud architecture is very flexible. So the first is with respect to orchestration. We can perform orchestration in the distributed cloud, which I think is really key, since it enables the ability to add, whatever levels of intelligence you want in a distributed cloud, and ultimately put that intelligence close to the customer premise. So if you do that, then obviously it has a lot of implications from enabling new services and lower latency models as well. It can also, I think, provide enhanced survivability to support, localized applications for users in the cloud. And kind of what I mean here is that it's possible, since it's possible to orchestrate applications in the distributed cloud, it's also possible that even if there's a failure in the centralized cloud, the services may continue to be supported in the distributed cloud if the intelligence resides in the distributed cloud. So there's ways you can provide localized application support. I think another aspect or another part of this that has to go is that it really creates a viable transformation migration strategy for migrating the legacy enterprise to the cloud. These are why use cases such as virtual CPU are so critical, because the best approaches to migrate legacy applications has really been, I would say, a very difficult transformation topic for a number of years. I mean, there's so much embedded proprietary technology in the legacy enterprise that being able to migrate that through virtual CPU by putting intelligence at the edge, I think, is really a key way of being able to handle sort of a transformational shift for the legacy enterprise. And finally, I would say you also have to consider intelligence and flexibility. So you can also leverage intelligence and flexibility of this distributed cloud to really provide the ability to support additional policy and even security enforcement capabilities at the network edge. And this is very much where they're needed, because obviously as we move intelligence to the edge, we want to have the ability to also apply policies and provide security access to applications. So I think that's it from a technical perspective. From a business perspective, I think there's a number here, and these are probably things you've seen before as well, so we'll go through them and just summarize them. But I think it can be broken down into four groups. The first is service agility. What I mean by that is, shorten the service delivery time frame. It also enables more end-user control, so through automation, kind of the notion of giving the end-user subscriber the ability to automate and provision some of their own services via portal. And also, I think the distributed cloud kind of fuels the wholesale services, so this kind of extends the reach of software as a service to the edge. And I think that whole model of extending software as a service to the edge is very strongly in line with the future and requirements associated with Internet of Things, which really will be, in essence, edge applications in many cases. And then I would say OpEx reduction, being able to reduce customer care and customer support costs, reducing truck rolls. That has a strong function as well. And the idea here is that by supporting analytics and understanding and having the intelligent applications run on the edge, you can have a really good view of the customer models, and being able to use that automation can allow subscribers to kind of provision their own services. And then obviously CapEx reduction. So this is, as I said, the distributed cloud really is the most cost-effective model. You can scale at the edge based on demand, and you can purchase and spin up resources, VNFs, based on demand and business growth. And then finally, I would say the last part is customer experience management. So this is something that really allows you to, especially if you take analytics with Customer Experience Manager, really is able to drive a major improvement in customer experience management overall. And I think this not only helps retain customers, I think it also helps ensure that SLA levels are being met on a network level. So those, I think, the drivers. I've gone through them fairly quickly, and Wayne will be touching on these points in more detail. But before I turn the presentation over to Wayne, we did want to just conduct our first poll question and get your view on these drivers. So the poll question for the audience is, what do you consider the top business driver for deploying a distributed cloud? Is it service agility, OpEx reduction, CapEx reduction, or customer experience management? So while we're waiting, Wayne, any sort of ideas of how this will play out from an audience perspective?
I think they all have unique values to the distributed cloud. But if I were to choose one, I'd probably say service agility is what I'm seeing across the board.
Okay. I don't disagree. I agree with that, but I would like to, I would sort of put in my dibs for customer experience management as well, as I think I'm starting to see a lot of my discussions with operators that customer experience management is becoming a really key part of this as well, especially for distributed clouds. So let's push the results. Oh, you were way ahead of me. Good work. So 63%, service agility, OpEx 10%, CapEx 14%, and then my customer experience management was third. So again, it's interesting. You know, we've been doing research on this for at least 2.5 years, 3 years, and service agility has always was sort of first at the gate, and it's still very much a key driver. And I have noticed also sort of the CapEx reduction is also becoming a little bit more important as well. So that kind of confirms that. So again, no, I don't think there's any surprises for you, Wayne. You basically kind of agrees with your views.
I bribed the audience.
Okay. So with that, what I'll do now is I'll turn the presentation over to Wayne so he can discuss in detail, you know, the business and technical considerations for implementing the distributed cloud. So I'll push out your first slide, and please go ahead, Wayne.
Okay, thanks, Jim, for that excellent overview. So what I'm going to cover really is a lot around the implementation of this distributed cloud. But I'm going to first start off with a couple trends that I'm seeing as well. Now, in terms of this cloud as we know it today, you know, I don't think that there's any argument that cloud proliferation is happening like wildfire, right? There's just more and more workflows from the enterprises that's shifting up into the cloud. But as a result of that, I think what we're seeing is how do we start to look at differentiating the services that are delivered from the cloud instead of just having centralized models that might be delivered over the top. You know, how do we leverage a service provider's network to gain the best advantage of this? So this is the topic of the distributed cloud. Service providers have many locations across the world that are distributed to connect customers to the network. In these locations, now with virtualization, SDN, NFV, there's a great opportunity to push some of these services, these cloud services, in a distributed manner into these locations. And that's what we'll heavily focus on today. How do we differentiate, though, by this approach? There's great economies of scale that can be managed through this distributed approach. There's optimization of applications that are better served because of SLAs, closer proximity due to latency. There's all sorts of different application specifics that could be better optimized in a distributed manner. Redundancy, the ability for certain applications, if cloud connectivity for whatever reason happens to fail, we have redundant capabilities for that application in a distributed way. Better SLAs, which I touched upon. And a key element of this is now with central orchestration of this, the ability to abstract that network layer, abstract where these services actually live, and then be able to orchestrate that in a centralized manner allows great operational efficiencies for this distributed approach. So why do we care? Obviously, from a customer benefit, there's workload improvements that can be delivered in this fashion, benefits of maximizing the benefits of virtualization, and then therefore really driving utilization of these services, whether that be because they had a better experience or whether they are able to manage capacity designs of this so that we have the right size model for the adoption rate of that particular service. There's tremendous benefits that we can gain across the board. So let's take a look at this particular slide, which really illustrates the value of the platform in order to deliver those services. We all know that the key value is moving up the stack and delivering platforms, delivering services, delivering content. But we look at really historically, through much of the 1900s, voice was really the predominant application here, and the platform to be able to deliver that, well, voice quality probably would be the key, right? Then as we move over time, long distance was added. But as we got into the 2000 to 2010 period, voice was becoming not so much of a cash cow towards this. Adding data internet services was pretty popular. But again, not so much really about content or services. Moving really into the present time, the value we see is heavily influenced by the platform. We see this with AWS, Rackspace, and a whole host of other type of platform as a service or infrastructure as a service type of capabilities, right? And, the key is really the delivery of the services and content across those platforms is really split between those two where the cash cow is today, and delivering that greater experience to the end customer, either through, better quality of experience, through the customer experience management that Jim talked about. All those things are key principles. So if we were really to look at this present value to the customer, how do we uplift this so that we create a level of differentiation? And this is really the topic of this distributed cloud. Having this platform to be able to further improve upon these principles is where we think this future is going to go. And the telco cloud, or the service provider's distributed network, really turned into a cloud, is really where we can reap really a lot of benefits associated with this. So with that said, let's take a look at the structure of what that network might look like, right? Where would we physically look at distributing this cloud from a topology sense? So if you look at this particular slide, and I first show really the national data center. This is where maybe your heavy iron is placed. A lot of your virtualization, compute power, storage, as well as your management and orchestration capabilities associated with the cloud would look or would sit. So some applications are very well suited for this particular data center approach or centralized approach. But we'll discuss some of those. But some applications are really not as well suited with this particular centralized approach. And if that's the case, this is where we start to look at the broader topology and say, well, where could we really start to leverage that network and place some distribution? Regional central offices is a great location to expand upon. Compact COs or POP locations would be yet another way to further distribute these services, still leveraging the same principles that are sitting within that data center, leveraging OpenStack, leveraging key API templates for service templates and so forth, being able to orchestrate the services and applications out into a more distributed location. And really now what we're seeing is even taking that out further to a software-driven CPE, where it has compute power running on x86 that can can serve these virtual network functions that what might otherwise reside in these other regional COs or national data centers, but leveraging exactly the same principles, but being able to push that out to the customer prem and management of this really from that central orchestration layer. So that's really the essential topology viewpoint of this. The other aspect of this is taking a look at it from a more of a cloud development DevOps approach. The providers are really struggling, right? There's all these applications that they have to worry about. How do they deliver that great experience? Is it OTT? Is it SLA driven? Is it application dependent upon that? And then now we introduce the virtual network functions to be able to abstract network capabilities onto a virtualized platform. So yet another element of things to think about. So lots of things on your mind. So today, if we look at that centralized or cloud approach, right, there really is several key principles that are driving the accelerated delivery models of services, the agility of being able to deliver services in the way that customers expect, right? And these are really dictated by things like agile workloads, workflow orientation, so that we can start to customize and automate that customization towards what the application-centric view of the customer is. So more personalization of those services. Being able to elastically grow, sort of this on-demand mode of these capabilities, so that as a customer, they don't have to purchase large blocks of these applications and services up front. They can really start to adopt these and buy these services as the need is there. So, but that takes an incredible amount of automation and virtualization management capabilities to be able to deliver that. Then with sort of this DevOps approach model, taking the analytics, taking the data from the network, from the application, and serving that up to better improve the capabilities to the end user is a key element to constantly evolving and improving the services that you're delivering. And lastly, really an open model to this approach, both in terms of open source, open standards, consistent data models, such that we can become much more vendor agnostic in these approaches, so that when we build this, we're not tightly coupled to a specific physical infrastructure below. So these are really some of those key principles in that centralized model. And so what we're saying is, well, if you can add to this, right, with this highly distributed cloud model to better fulfill against these same principles, we're going to see a much better delivery model of these applications and services. So those are some guiding principles as we look into this. So let's take a look at a very specific example, right? Traditional CPE-based approaches. We all know the challenges of this, really, with dedicated appliances that sit on a customer premise. They are very customized, very purpose-built. They often require truck rolls for delivery of these capabilities. But when we look at the development of those capabilities and services to roll out into the market, so the service creation side of it, that development can still take months, 6 to 9 months of time to roll out a new specific service to add into, let's say, a chain of capabilities. So if we look on the right here, we may have flavor 1, flavor 2, but each time we add one of those flavors to the mix, the development of that new service capability into the mix takes a long time to do. So this old way of developing and delivering CPE-based services to market really doesn't serve against what the customer demands are for that on-demand model, customization model, and control of the service really within their hands, right? So let's use this as an illustration of, well, how could a distributed cloud leveraging SDN and NFV technologies benefit this specific application? And we'll use this as an illustration and a couple others as well. So what we're really seeing now, and I know that many of you have probably seen the trends around this, is the virtual CPE, what Juniper calls cloud CPE, a way to deliver those CPE-based services in a centralized model. So if you look at this diagram on the left, up at the top right corner, you'll see that centralized cloud where the traditional CPE services, whether it be firewall, load balancing, analytics, unified threat models, all these things can now be virtualized and live up within the centralized data center, let's say, right? And so that's a very good approach to bring it to a larger market, maybe serving the SMB market very well for that type of deployment model. With that centralized orchestration. So tremendous operational benefits that can be gained for this, right? Simplifying that service delivery, reducing the truck rolls that are necessary with the traditional models, providing really greater economy of scale so that we can deliver these services with great operational simplicity and being able to bring these to new markets with the centralized approach. And at the end of the day, really a cost of ownership optimization of the services that you're bringing to market. So these are all very much critical factors of this. But what if we could now, take those same services and push that out to some of the additional real estate assets that the service provider has, such as the provider edge. So that's what the red arrow down to the next-gen CO would illustrate, is being able to push those similar like services with that centralized orchestration layer down to your next-gen CO. So reaping the same benefits, but bringing these services and applications closer to the end customer. So let's take a look at, from a topology standpoint, how does that place out, right? We have this element of a catalog-driven model for these sets of services, or what some are now calling a marketplace for services that they want to build up in their cloud-based element, right? And with this capability, we start to really build up a suite of services that can be potentially rolled out at different places within the network. So we talked very much about the DC cloud-based model, the centralized cloud CPE as one way to build out that capability set. But let's say, as an example, you have educational systems, which now is digesting and consuming video content significantly. But if you look at the college cycle, right, it's either a quarter-based system or a semester-based system, so it's very cyclical, and it has certain times and so forth that are peak hours for, or peak time frames for those type of services. So with a virtualized model, we can really start to scale up during peak seasons, and the ability to scale down during the times that they're in an off session. But bundle that with video, very latency-centric, better to push those the content, like CDN-based video systems, out to the edge of the network. So what if we could push that CDN capability out to the edge of the network and distribute those services along with the CDN-based VNF for that content delivery closer to that university. So with this type of catalog-based driven system, the ability to abstract that network service layer The customer could then come in and say, I want a video content delivery-based network. I want that orchestrated across a specific set of customized service details. And I'd like that to be pushed down to a location that best suits that. So as a provider of that service, you have a better awareness for, well, that service would be better served, let's say now at that distributed edge. So that with that network level abstraction, the service could easily be pushed down to that layer and better serve that customer. So that's really the approach of this, is leveraging that asset, leveraging the network level abstraction that we gain with intelligent controllers these days, and with a service orchestration layer that has better intelligence of where the service best would live. So that's really the bundling of this capability. Now let's take a look at it being even a further illustration of this capability set. So we talked about the data center approach. We talked about the next-gen CO approach, pushing it pushing out closer to the edge. But what if we could even take it out further, leveraging the same principles with virtual network functions, and leveraging a compute platform that resided on the customer premise. And so, still centrally managed, but with the ability to leverage the benefits of virtualization out at the customer premise location. So this would be very different than a highly purpose-built CPE device. Juniper just announced something called NFX that does this, but basically it's an x86-based platform that allows the end user to easily, in minutes really, to install this device and connect it up to the network. And after that connection to the network, it would do a self-install of those applications and services that are needed. Now, what type of applications would really suit this highly distributed model? If you think about, encryption services, or if you think about, let's think about a hospital as an example. Hospital, again, also has a tremendous amount of video consumption these days for imagery and pushing that out to clinical locations that might require other people to review an image that was scanned. Now, with that, there's going to be encryption requirements for regulatory reasons of that, as well as maybe some WAN optimization to push that video asset out to a different location. So these are things that really cannot be completely centralized, even if we want to leverage the benefits of virtualization. So in that particular case, a CPE device that can leverage VNF principles, where you can load encryption VNFs, you can load WAN acceleration VNFs onto there, and be able to still centrally manage that. That's really a perfect model for how you serve that customer better with better SLAs, but being able to deliver that with a faster path to revenue and greater service flexibility to be able to deliver those services. So that's kind of the model that we're talking about here. And to take the illustration, in that same topology point of view, what we're really now doing is just leveraging here on the left a software-driven CPE device that has the ability to run those VNFs. Now, in terms of the connection model for this type of an approach, this could be done in a managed access layer 2 type of tunneling, or it could be even done as an over-the-top service like an SD-WAN model, so that you leverage your existing internet-based connection models, but secure that with some IPsec VPN tunnel across that circuit or across that internet connection back up into the cloud. So lots of different optionality flavors of this, but the key is really providing an optionality with these different approaches and the placement of these services. And again, the service orchestration layer Juniper has one called Contrail Service Orchestration, really has, again, the intelligence to pull from that catalog or that marketplace of services and best design this placement of applications into a distributed cloud network as illustrated here. So where we started with this conversation is really about a platform, right? Is that we think that this is where the differentiation, the gold mine is for a provider to unlock opportunities in this new world of service delivery and cloud service delivery. We've defined that distributed service provider cloud, right? Data center, regional COs to POPs to now even the customer premise. The entire network spectrum is your cloud now. It's really defined as a way to deliver these services in this centrally orchestrated way. If you then move up the stack and look at the broad range of services you can offer through this type of model, network services to a whole wide range of security services, mobile services, storage and compute services, and then moving really up to the services and application layer, there's really a wide range of capabilities. But the key to this principle is that you're building upon a NFV framework, an architecture that really enables this capability set, right? Whether that be in your NFV infrastructure, whether that be in your management and orchestration layer, or whether that be in your virtual network functions that have the ability to be distributed like this. That's going to be very key to this platform approach in that it has the ability to offer it in this distributed way. Jim touched upon this in terms of the self-care portals, right, giving that excellent customer experience to the end user, but abstracting the fact of these complexities to the end customer. They don't need to necessarily be aware of all these complexities, but the provider to differentiate should have these capabilities to do so. And then extending that really beyond their own cloud. What we're now seeing is cloud service brokerage, where we have greater cloud-to-cloud connectivity to bridge those capabilities of additional cloud services, but deliver that to the end customer with that same SLA guarantee that they have for the managed network connection model. So really this unlocks a tremendous amount of opportunity. And let's take a look really now in terms of, well, let's look the stages of how to develop this type of capability set, right? What are the key elements and procedural steps to be able to get this done? So we'll start over here on number 1, where we talk about the network service designer. This is essentially what I call the playground, the place where a service provider who is thinking up ideas from a service creation perspective to be able to build up that catalog or that marketplace per se, and using what we call a graphical user interface to be able to construct that service capability set, and also potentially the chaining of those services together as to how the consumer or the end customer might need to consume that capability or a couple different services and applications together. How might that look like? So this is their playground to be able to instantiate that. Then we get to step number 2, which is, well, I've got the service catalog built up now. How do I begin to operate and manage and automate the delivery of that service to the end customer? And this really begins the engagement of the entire service lifecycle management process and the tool sets to be able to construct that. Then number 3 really is the interface to the end user, the customer interface portal, really because we're moving into a world where we need to provide that end user a self-care portal to remove the operator's manual processes from that ordering process and that fulfillment process. And even after the fulfillment process, into the entire lifecycle management of that, giving the end user that portal to be able to have visibility towards that. And then lastly, step 4 is pushing this into that distributed cloud so that regardless whether it's a physical network function or a virtual network function or the location of that, there needs to be the ability to orchestrate this end-to-end across the entire service provider network. So we'll delve into a couple illustrations of this here. The first is that network service designer in terms of service creation, the step 1 that I showed you. And this is really where we start to build up that catalog of capabilities in the service provider's marketplace. But again, key principles of this is that it should be DevOps driven. There should be an agile development process to this. And there should be a reusable catalog of services to deploy across the distributed cloud domain. So with that set of principles, stage 1 is really using that service designer and being able to construct the service catalog and put that into your marketplace. But that also means that we'll have to interface with existing OSS, BSS systems, billing systems to ordering systems to finance systems, and making sure that that whole entire operational cycle is integrated. And that's very much done through an API-driven, RESTful set of APIs driven up to the OSS, BSS layer. The second is to be able to push that service template, the order by which maybe a certain suite of services. We covered sort of option 1, option 2, and there might be several other options. Being able to present that service catalog to the end user in an elegant way so that they can order that set of services. And then the third step is really the configuration template element of this, is to be able to take that set of services going down to your VNF and PNF managers and orchestrate or automate the implementation of those services across your distributed cloud. So that's the notion of the service designer. Second is, well, okay, I've built up now my services. I have a good idea of what I want to present to my end customer. So that's the portal presentation of those capabilities. So you'll dig into your catalog, present that up, serve that up to your customer. The customer then may order a set of services. So through that catalog, we should be able to push down a set of service templates. This isn't specifically, configuration of a router or a switch or something like that, but this is really about, I want to have that customized service implementation automated through these heat templates. But that then needs to get translated down to the virtual network element and being able to push that down to the location where that virtual network function would reside, again, across that distributed cloud. So that's really sort of step 2 in this management process of how to automate this type of procedure. Now, if you take a look at one really specific element of this, and Jim touched upon this earlier, is service chaining. This is where the blend of the physical network element and the virtual network element really need to get stitched together, in that we need to be able to route a specific data workflow through certain virtual route functions, VRFs, and into specific flows across the virtual network functions itself. So on the left, we have the MX, really your edge platform. So let's say this is in your POP location, and then we want to chain that across a set of services that the customer has ordered. And in between that, there might be certain policies and security enforcement rule sets that need to be placed so that we adhere to certain demarcation points that need to exist between certain applications. So this service chaining capability, as orchestrated through our Contrail platform, begins to really automate these procedures so that you don't have to, manually stitch these sequence of events together. So now that the service is built and ordered and fulfilled against, we get into the cycle of monitoring the service and how it's operating for the user. So there's monitoring, there is correlation of the data so that we can better serve up the service going forward to the customer. And there might be some self-healing principles that need to be applied. So the key element here is that across the distributed cloud, there has to be data elements that are fed up to our monitoring system. That monitoring framework will then provide input back up into our service orchestration layer, which would give reports to the end user, which is key, right, so that they're aware of what might be happening within their network. But as well, with the self-healing elements of this, be able to provide specific instructions back into the network itself so that we can fix those issues in an automated fashion. So this is that sort of cycle of time where, the life cycle management of this exists as the service lives on. And this could also be true for, providing the self-care portal reporting of how well, what's happening with the service, what's my consumption, do I need to potentially grow that service over time. So a lot of elements here within this monitoring and healing phase of it. So really to wrap this part of it up really is, stepping back, is that there are many stages of this orchestration across the distributed cloud. And this slide really helps to summarize between the network service designer to the administration and customer portals down to the network service orchestration layer. What are some of the key functional elements that each of the stages has to be aware of and work through? So I'll leave this really as a reference slide for you so that you understand some of the elements that has to be worked through. So really with that, let's bring this back up to a platform approach. This is what Juniper is looking at in terms of our end-to-end NFV solutions approach. Now, I'll layer this approach in terms of starting out with the NFV infrastructure. The NFV infrastructure is really one of the most essential elements in terms of the distributed cloud, because this is where the devices that exist, whether it be in the CO, the data center, or at the customer prem, it needs the capability to work with the management and orchestration system to fulfill against this virtual deployment of VNFs. And so, these devices now have been very purpose-built for working within this architectural context. Now, the other element, of course, is the virtual network functions. Juniper has platforms specifically to enable a broad range of virtual network functions with the virtual SRX and virtual MX. But the key to this is that we're building up a service catalog. So third-party virtual network functions is a key element to our open platform approach to be able to build this within, to push this down to our NFVI, as well as to integrate this within our management and orchestration layer. So looking really at our management and orchestration layer, it's comprised really of three major building blocks here. First is the Contrail Cloud Platform, which has the Contrail networking element to provide PNF and VNF configurations, as well as Contrail Cloud, which has the integration with OpenStack for compute and storage management in a cloud environment. We have our Contrail Service orchestration layer that performs many of the tasks that I just walked through in terms of from the network designer to the instantiation to the continual monitoring elements of a service lifecycle. And then our Northstar WAN controller, which has the ability to better do traffic management of things across our WAN network for this traffic flow. So the key of all of this is that each of these elements is built with automation in mind so that we can take out much of the manual operational steps in these approaches. And then the wrappers around this is that we've got a whole service lifecycle management program, as well as end-to-end support services from our professional services side to help with these type of engagements to work through these platform design issues. So in summary, what we've gone through here is a distributed cloud approach, first and foremost for service delivery. We saw in our first poll question that agile service delivery is top of mind for a large part of the audience here today. And so to build that relevance to the end customer, and as a result of building that relevance to the customer through rapid service delivery and the ability to meet better SLAs and better experiences with the applications you're delivering through this distributed cloud approach, the result of that is you'll be able to open up new markets, open up new market segments, locations, geographies even, and really attack the vertical problems that the customers are facing in a better way. Second is really the automation approach of this, right? Especially with a distributed cloud approach, if we don't have the ability to remove the manual operations away from these processes, it will be very, very difficult to build up a distributed cloud in this approach. So, automation is top of mind, and through automation, really, we're going to help your competitiveness in terms of lowering your operational expenses, as well as really reducing any truck rolls that might have previously existed in the delivery of these services. And lastly, this is really the summation of this distributed approach. It's optionality is what I call it, right? Having agile and flexible models to serve your customers better, whether that be a centralized approach or whether that be a decentralized approach or whether that really be a hybrid nature of this stitching together. It gives you the flexibility to tackle these applications with a new platform that better serves your end customer. And Jim, with that, back to you.
Okay, great. Thanks, Wayne. So excellent presentation. So we're going to get to the Q&A in a minute, but before we do, we want to ask you, the audience, what you want to conduct our second poll question. What you believe is the greatest distributed cloud implementation challenge? Is it, these are some things that Wayne's touched on, is it lack of geographical presence? Is it lack of management and operational capabilities? Is it inflexible infrastructure? Or is it that you have certain VNFs that cannot support this model? So Wayne, as I said, excellent presentation. While we're waiting for the audience input, there is a question we can get to here from the audience. The question is basically, are the distributed cloud security policy challenges different from that of the centralized cloud?
Yes, they do actually present an additional set of policies and enforcement rules, because now you're really looking at potentially having different demarcation points. So let's say you have a set of DNFs that live out at the customer prem and some that are mixed in with your centralized cloud. Because you're exiting a demarcation point, there may be security policies about the that the enterprise enforces for exiting the location. And those need to be very much considered within that, that orchestration layer to understand that there's going to be those policy approaches between demarcation points.
So kind of more granular policy on the demarcation points in essence.
Yes.
Okay, let's see what the audience said. Okay, so the number one was lack of management and operational capabilities, 59%. Lack of geographical presence. Any surprises here?
No, I think that is very much consistent with the challenges that we're hearing, not only just from distributing this stuff, right, but also just purely from a SDN NFE approach to be able to manage virtual network functions. This is pretty consistently the number one response, and so that's why we spent a big focus on addressing this with our Contrail platform. And is it done? Absolutely not, right? This is a continual journey that we need to partner with you as a customer to evolve. But we feel that we've taken some significant strides, especially with our recent launches, to address this for better accelerating the delivery and delivery of this in a distributed way.
Great, but maybe I'll just put in here, I mean, from my perspective, though, there's certainly, you said the challenges, you've done an excellent job of summarizing the challenges, but certainly the sort of the service benefits, sort of the service chaining stuff, to me, is kind of a key driver that will, is something that operators really need to address, for sure, in their new service models. Okay, before we get to Q&A, I'll just maybe push one slide out here. Is there anything else you want to summarize, Wayne, before we get to the Q&A, the formal part of it?
Yeah, I would just invite everyone to take a look at Juniper's site. We've recently launched our NFE approach called the Big NFE Idea, and you'll find lots of material associated with this distributed cloud approach, as well as really the themes around service creation and automation in this particular location. So I invite you to take a look. We're very excited about this new market and these new approaches. And we'd like to share some of those ideas with you through this location.
Okay, great, thanks. And just even that QR code that's up there now, that will actually work from this platform as well on your smartphone. We tried that in the rehearsal. Okay, so let's just move to the Q&A part. But before I do, I just want to push out this link for you, the audience. As the operator said at the beginning of the call, we would encourage you to provide feedback on today's session via this link to help us serve you better in the future. So. Okay, so let's try some of the questions here. I'm just going to go through them. There's about a number of questions we can, I think, get to. Okay, the first question is, are you seeing operators implement service chaining today? So yes, service chaining, I would say, it has a very sort of crawl, walk, run, focus on it, right? Because I think initially you have to start off with some very prescriptive, precise models that you're trying to attack your customer services with. And those service chains may or may not be that complex. Physical network and virtual network blending, absolute, right? But in terms of how deep those service chains go, I think we're still starting to see the beginnings of that. Maybe 2 or 3 different services or 4 services chained together. And over time, we're going to see even a greater chain of those services together. So yeah, I think we're really starting to see the beginnings of that, and we'll see much more complicated service chains as we go along. Right, and maybe just to point out here too, in that sort of that legacy or that traditional CPE model, service chains would be almost impossible to create because you wouldn't have sort of software capabilities, so you'd have to kind of have a static network model and run all your traditional CP services through, security gateways, firewalls, and things like that. So this is kind of new capabilities that I think does have a real impact on services. Okay, and maybe one other question we can get to is, what types of services are leading the implementation of distributed cloud? You talked about CP. Are there others as well, I guess the question is?
Yes. So I think the low-hanging fruit, and the one I think the market, just about everybody is talking about, is virtual CPE. So that is a blend of network-based services as well as bringing in security services that are virtualized, virtual firewall, web content filtering, IDS, unified threat protection models. So those are definitely the ones that are driving the early adoptions of this approach. Going forward, we'll probably see extensions of that into that virtual CPU segment, whether that be WAN acceleration, wireless LAN controllers, and so forth. But we're also seeing things like content delivery network being one I alluded to here in this presentation, being a prime driver. Because if you look at that distributed cloud, that's probably one application that above all, may benefit greatly from this distributed cloud approach. So those are some of the leading ones, but I think that there's a whole host of other ones that are being discussed, but probably more being demonstrated through proof of concepts than they are deployments at this stage.
Right. Okay. Unfortunately, we have to leave it there. So, Wayne, excellent presentation. So, I'd like to thank Wayne for presenting today. So I'd also like to thank you, the audience, for attending today's session. So on behalf of Light Reading and Wayne and Juniper, this is Jim Hodges. Thank you for attending. We hope to see you again. Thank you.